Let's be honest, if the words math class still make you break out in a cold sweat, you are definitely not alone. But what if the problem was never you? What if it was the way you were taught? We're going to dive into the new way we're teaching math, and believe me, it's changing everything. You know that feeling, right? That little knot of anxiety. For decades, math was taught like this rigid world of right and wrong answers. There was one right way to do it, and a million ways to get it wrong. But what if we've been looking at it completely backwards? What if the problem isn't us, but how math has always been taught? So to fix this, educators are making a really fundamental shift. Seriously, it's no longer just about cranking out the right answer. It's about something way more important, learning how to think. To mathematicize, I love that word. It's such a powerful idea. It's not about cramming your head with formulas. It's about learning to think like a mathematician, to see the hidden patterns in the world around you, to reason logically, and to tackle problems with a bit of creativity. The whole idea is that this way of thinking is like a superpower you can use in any part of your life. Okay, so what is the ultimate goal here? The famous mathematician George Polya said that math education actually has two different aims. And getting the difference between them is absolutely key to this whole new approach. So on one hand, you've got what we call the narrow aims. These are the practical skills you might need for a job, like calculating percentages or taking measurements. But then, on the other hand, you have the broad aims. This is about developing your mind, learning to think logically, and becoming a really flexible problem solver. And the argument today is that for way too long, we've been so focused on the narrow stuff that we've totally missed the bigger, more important picture. And this change in philosophy, it has to start at the very, very beginning, right there in primary school, when our relationship with numbers is first being formed. The core idea here is actually pretty simple, but it's profound. You don't start kids off with a bunch of abstract symbols on a page. No way. You start with things they can actually touch and see. You're basically building a bridge from the real world, a world of blocks and apples, to the abstract world of numbers and equations. So what does this actually look like in a classroom? Well, according to national curriculum guidelines, it's all about puzzles and play, not just boring drills. It's about exploring shapes and patterns. It's about turning math into a conversation, not some silent, solitary test. And maybe, most importantly, it's about making sure every single child believes that they can do math. Okay, so that's the big idea, but how do teachers actually bring this stuff to life? Well, let's take a look at the tools of the trade. Think about the old school way. Here's the rule, now go solve these 50 problems. That's the deductive method. But the inductive method, it flips that completely on its head. It says, hey, let's look at a whole bunch of examples and see if we can discover the rule together. It turns students from just being passive rule followers into active mathematical detectives. It's a game changer. And a huge part of this is using physical tools. Take the geoboard. It looks so simple, right? It's just a board with some pegs. But you give a kid a few rubber bands and suddenly they can create shapes, explore area, and literally see geometry come to life right in their hands. Then you've got the abacus. This ancient calculator is an unbelievably powerful way to make abstract ideas tangible. Kids can physically feel what it means to carry the 1 or borrow from the tens just by sliding those beads themselves. Diane's blocks are another amazing tool. A tiny cube is 1. A rod made of 10 of them is 10. A flat square of 100 is 100. All of a sudden, this really abstract concept of place value becomes something you can build and hold. It's learning by doing, not just by listening. Now, this whole hands-on thing isn't just for arithmetic. It also completely reframes how we teach subjects like geometry. We now see it as a developmental journey. The Van Healy theory shows us that understanding geometry happens in stages. At the very first level, a kid just recognizes a shape by how it looks. That's a square because it looks like a box. Then, at the next level, they can analyze its properties. Oh, it has 4 equal sides and 4 right angles. They keep progressing all the way up to being able to write formal, complex proofs. The really crucial insight here is that you can't skip levels. You have to build that understanding step by step. So, what's the end game here? When we combine this new philosophy with these really cool practical tools, what are we actually trying to achieve? The ultimate goal is that mathematization of thought, teaching kids how to think. It's about helping them actually enjoy the process of solving a problem, not just rushing to get the answer. It's about connecting math to their real lives, and above all, developing clear, logical thinking that's going to help them in everything they do.
This new approach helps us escape what's sometimes called the tall and spindly curriculum. You can picture it like a really rickety tower of blocks. If you miss one crucial block way down at the bottom, say fractions, the whole thing just comes crashing down later on. The goal is to build a curriculum that's broad and strong, not some fragile one-way path.
So we'll leave you with this question. What if the goal of math class was never to produce a bunch of human calculators, but to cultivate a generation of curious explorers and confident problem solvers? That's really the promise of this new way of teaching math, a promise to change our relationship with numbers, one classroom at a time.